Hi everyone, welcome to Focal Academy. See this problem. Here Design L Attenuator Circuit. Here two cases are given here. This is case 1 and this is case 2. In case 1, source resistance is given as 75 ohms and load resistance is given as 50 ohms. In case 2, source having only 10 ohms and load having 50 ohms. So before going to design the L Attenuator circuit, first of all understand what is L Attenuator circuit. Let's see here. This is source here and having some load. The source having more signal strength, but for load we need some signal strength. Suppose this is a signal, but for load we need a small signal. So for that we need to reduce the signal strength. So for that we are going to use attenuator circuit. So attenuator attenuates the signal from source to load. This is the attenuator. We have different types of attenuator circuits are there. So attenuator is a resistor circuit. It consists of only resistor components. In this video we are going to study about L attenuator. What is L attenuator? First of all, in L attenuator we are going to use only two resistor components. Based on source resistance and load resistance, again L attenuator was classified into two types. So whenever source resistance, that is Rs, is greater than RL, we have one circuit is there. So whenever source resistance is less than load resistance, we have one circuit is there. But the design is different, but it contains only two resistor components that are in the shape of L. So that's why it is called as L attenuator circuit. So let's come to the circuit. These are L attenuator circuits. So here voltage source, and this is source resistance, and this is load. Here R1 and this is R2 and this is R3. So whenever Rs is greater than RL, we will use this circuit. So whenever Rs is less than RL, we will use this circuit. So here this is in the shape of L. That's why it is called as a L attenuator circuit. Now how can you find R1 and R3, R2? So in the first case, the source, that is Rs is greater than RL. So here RL is only 50 ohms and Rs is 75 ohms. So at the time we are going to find R1 and R3. In second case we have Rs is less than RL, that is 10 ohms less than 50 ohms. So at that case we are going to design the circuit, that is this is. So we are going to find R2 and R3. Now how can you find R1 and R3 for the first case? In second case we are going to find R2 and R3. How can you find? First of all we are going to design the first case attenuator circuit. So for that we are going to choose this circuit because here Rs is greater than RL. So let's see here. So this is the circuit. So in the circuit we need R1 and R3. So here Rs is greater than RL. So Rs is given as 75 ohms greater than 50 ohms. That's why we choose this L attenuator circuit. Now how to find R1 and R3? We have a standard formulas for finding R1 and R3. So that is R1 is equal to root of Rs into Rs minus RL. Now substitute. So root of Rs was given as 75 ohms. 75 into 75 minus RL is 50. So by simplifying this we will get 43.3 ohms. Next we need R3. R3 equal to RS square minus R1 square upon R1. These are the standard formula for finding R3. So here R1 we got 43.3 ohms. Now substitute this value here, and RS is given as 75. So from this we get 75 square minus 43.3 whole square upon 43.3. By simplifying this, we will get 86.6 ohms. This is R3. So for the first case, R1 is needed 43.3 ohms, and R3 we need 86.6 ohms. Now in second case, how to find R2 and R3? Now case 2. So here in case 2, 10 ohm source and 50 ohms load. Now how can we design L alternator for the case 2? So here RS is less than RL, so at the time we use this circuit, that is 10 ohms less than 50 ohms. So in the circuit we need R2 and R3. How can you find it? R2 equal to root of RL into RL minus RS. That's equal to root of RL is given as 50. 50 into 50 minus source is 10. By simplifying this, we will get 44.72 ohms. Now we need R3 for case 2. That is R3 is equal to, so this R3 and this R3 is different. Okay, so this R3 is for case 1 circuit. Okay, now we are going to find this is the R3 for case 2. So that is R3 equal to RL square minus R2 square upon R2. Now substitute the values, we will get RL is 50. 50 square minus R2 we got 44.72, that is 44.72 whole square upon 44.72. By simplifying this, we will get R3 equal to 11.18 ohms. So in same case, we need the first resistance is 44.72 ohms and the second resistance is 11.18 ohms. And this is process of designing of L attenuator circuit. And thanks for watching. Please subscribe, like, share. Thanks.